Welcome back. Now we've just seen the process of completing the square. That's kind of a pain to use in general because it just takes so many steps. But it turns out that if you complete the square on the actual equation, using exactly the same steps that we did on the previous example, you get what you should remember as the quadratic formula. Quadratic formula is one of those things that once you've learned it, you won't forget it. Okay? And what the quadratic formula does is it lets us solve a quadratic equation, any quadratic equation, as long as it's in standard form. Okay? We don't want a to be 0 because if a is 0, we have a linear equation. So if your equation's in standard form, then you can use the quadratic formula, which I'm sure you've seen. It's just minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's our quadratic formula. And like I said, try it. Complete the square on this equation. And see that you get the quadratic formula. And if anyone likes to see that, it's done in your textbook. If not, I'll be glad to work through it with you in my office. Okay, let's solve some problems using the quadratic formula. All right, now on the first example, one thing I notice right off the bat is that I can reduce. And if I do that, it will save me some hassle in using the quadratic formula. You can check that it works in both versions, but I'm going to use the reduced version here. And if I do that, then I have to identify my a, b, and c in order to use the quadratic formula. So a is just the coefficient of x squared, which is 1, b is 4, and c is 4. And then I just plug it into the formula, which again tells me the values of x that are solutions to this equation. So x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay? And that is negative 4 plus or minus the square root of 16 minus 16 all over 2, which is negative 4 plus or minus 0 over 2, and that's just minus 4 over 2, which is negative 2. Okay? Now, it turns out that this is really overkill for this example because I can also solve it by factoring. If I take my original equation, I can pull out a 2, and I recognize that that is a perfect square. Okay? Notice that half of 4 is 2. 2 squared is what's added. So it fits our pattern. And then if I look at that, I see, oh yeah, there is exactly one solution. X equals negative 2. So this would by far be the easiest way if you observe that it factors, but if the problem asks you to use the formula, the quadratic formula works and gives you exactly the same result. Okay? For the second example, we have to make sure that we have the equation in the proper form, which means I have to have ax squared plus bx plus c equaling 0. So that's the first step that I have to take here, is to get this equation in that form. So if I multiply through, I get 6x minus 2x squared equals 3. And because I like my x squared term to be positive, I'm going to bring everything over to the other side so that I get 0 on one side of that equation. Okay, does everyone follow what I did? plus 2x squared minus 6x, and I already had plus 3. So now I know that my A is 2, my B is negative 6, and my C is 3. Why is B negative 6? Because the original formula has plus. It's plus B, so I want to think of this as plus negative 6. And that's why my B is negative 6. So be very careful about your signs. Okay? And so now I can solve. X is going to be B squared plus or minus the square root of, the opposite of B. Let me stop right here and correct that. So far ahead in myself on the formula, it's the opposite of B, so it's minus a minus 6 plus or minus B squared minus 4 times A times C, all over 2 times A. Okay, again, these are the values that I'm plugging into the quadratic formula. And sorry about that, it's the opposite of B, plus or minus the square root of B squared minus 4AC. So what are we going to get? Minus a minus 6 will be 6, plus or minus the square root of 36, minus, let's see, that's 8 times 3, 24, all over 4. So that's 6 plus or minus the square root of 12 over 4. Okay, now do I want to leave that answer in that form? And the answer is not. We want to reduce it as much as possible. So we continue working on this problem. We know that 12 is 4 times 3, so I can simplify within the radical by bringing the 2, the square root of 4, out. Now, am I finished? Well, no. Look what I observe. There's a common factor in each of those terms. I can factor a 2 out of the numerator, and I get 3 plus or minus the square root of 3 all over 4, and then I can cancel that, leaving me with 2. And so I get 3 plus or minus the square root of 3 all over 2. Okay? So notice the difference. In the first example, we had exactly one solution, and notice there were no radicals, and we could have solved it by factoring. Okay? In the first example. In the second example, we have two separate solutions, and they happen not to be rational, so we would not be able to solve this by factoring. And you can check it out. You can try factoring this expression. You won't be able to do it. Okay? All right, what about the third term? It's already in the right form, so I can just look at A as being 1, B is 2, and C is 2. So by the quadratic formula, x equals what? The opposite of B, let's get it straight this time, minus 2 plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Okay, that's the quadratic formula. And then when I go to simplify that, I get x equals negative 2 plus or minus the square root of 4 minus 8 over 2, which is negative 2 plus or minus the square root of negative 4 over 2. And we know that that is a problem because that is not a real number. And so we say that this equation has no real solutions. Now, we will see later on when we talk about complex numbers that it has a complex number solution, but in the real number system, no solutions. And the next question is, could we have predicted the type of solutions we have? And we'll see that in the next video. Thanks.